All right, so we are starting the material for exam 3. So today we're starting with radical expressions. So whenever you see the word radical, we're talking about, for the most part, a square root, that kind of symbol. There might be a number on the other side of the square root. So it's either going to look like this or it's going to look like this with some number right here. So like you could put 3 right there and it would be a cubed root, or sometimes there's fourth roots, but this is what we're working with in this unit. Okay. You guys can't use a calculator, so we are going to do all the problems like you can't use a calculator. Okay. When you're doing these, you have to think about each case. Like case 1 right here is if your number for your square root is even and the number on the inside is positive, you can actually do the square root if it's possible. Okay, so when there's going to be a couple problems on your homework that ask you what kind of square root that is, if you have this instance right here and like a is positive, you're going to pick the principal nth root. In your homework, it comes up as positive principal. So you might want to write that down, that's what it's going to look like in your homework. If you have an even number right here and you have this negative sign on the outside, you're going to pick that this is the negative root. And that is going to show up in your homework too. It's just like a little drop down menu. So you're going to pick which one works for it. If n is even, so if this number right here is even and then the inside is negative, okay, so the outside's even and then the inside is negative, it's not real. Okay, so if the inside is negative, if you want to write that, you can. If the inside is negative. But when it's odd and there's the a on the inside, it works. Okay, so if this number right here in case 3, this works for positive or negative. So I want you to write that. Works for positive or negative. Either one, it does not matter. So that's all I have for the rules. So make sure you get the rules down, and then we're going to do some examples. So on number 1, for 1 through 15, you're supposed to find the root, and you don't have your calculators. When there's no number right here, you're always looking for pairs. So I'm going to factor down 49, and I have to think like what times what makes 49. Okay, so when I think of 49, I think of 7 times 7. Now, when you're looking for pairs, you're looking for two numbers that are the same. And if you get that, these two numbers are allowed to come outside the radical. And you guys know that the square root of 49 is 7, but that's how it works, because on some of these numbers, it's not going to work out as nicely. Same thing on number 2. Okay, I know that there's a negative sign now on the outside of your radical, but we're still going to use the same approach. We're going to look at 121 and think about what times what makes 121. Well, 121 is a perfect square. It is 11 times 11. I have a pair, so the pairs will come outside. Okay. And then that negative sign that's on the outside, it just goes into the front. Okay. So this is allowed. When the negative sign is outside, your answer is allowed to be negative. Because I know earlier I said you can't have negatives inside. Outside, it's totally fine. Okay. Number 3. So on number 3, we have a fraction, and we haven't seen one like this yet. When you have a fraction and you have a square root, you're allowed to break up your square root so that it's on the top and the bottom. So I'm going to write it like this. I'm going to write square root 25 over square root 36. And the reason I did that is because I know that I can take the square root of both of those. Like when I factor 25, 25 is 5 times 5, and 36 is 6 times 6. So I know I have two perfect squares right there. So on top, I have the 5s. There, they broke out of the radical over the 6s are going to be on the bottom. And you're just going to leave your fraction like that. Okay, so we broke up the radical on top and bottom, and then we're leaving our fraction alone. Okay, let's look at 4. Okay. So 4 has a negative on the inside. Okay. So when there's a negative on the inside, you have to check what kind of root you're taking. Now, when there's no root there, you're taking a square root. Okay, so a square root means I'm taking a root of 2. Okay, so the 2 would go right here, but it's kind of silly to write it. So if I look back at my rules, okay, there's an even number and then a negative on the inside. And my rules say that that can't happen. So there is an option on your homework that says not a real number. And that's what you're going to put for right now. Later on in this unit, we'll talk about imaginary numbers and how to write them. But right now, this is the answer that we're using. Okay, later on that might change, but right now, this is not a real number. Now on number 5, this is the first time we've seen a number besides 2 on the outside of our radical. Okay. So we have a 4 right here, and that tells me that I want groups of 4 when I'm breaking my number down. So if I look at 625, okay, I want to think of two numbers that multiply together to make 625. Now you don't have your calculators, and when you're done with this, we're going to kind of fill out the perfect squares chart that the sub's going to pass out to you. But we have to think about maybe what times what is going to make this. It ends in a 5, so I know that I can divide this by 5. So 625 divided by 5 is 125. So I'm going to write 5 times 125. Now my goal is to get a group of 4. So what I'm going to do is I'm going to keep going with 5, and I'm going to see what 125 is divided by 5. So 5 times 25 makes 125. And now I have 2 5s, so hopefully I can get 2 more. And I will, because we know that 25 is 5 times 5. So when I'm doing these ones that have a bigger number, remember you're going to circle the group of 4. So these guys all make a group of 4. Okay. And so everything in the group of 4 comes outside the radical, and you only write that number once. Now, there's nothing left on the inside, because if you look at this, like we broke down 125, so we're not using it anymore. Like we already broke it down. It was 5 times 25. We're also not using the 25 because we broke that down to 5 times 5. Because I know sometimes it gets confusing knowing what comes out of the radical and what stays in. And we'll kind of look at those when we do some more numbers that don't break out as easily. On number 6, we have another negative inside. But this time our radical is a cubed root. It's an odd number, so this is allowed because you could have 3 negatives make this. So every time you have this situation, your answer is going to have a negative in front of it. Okay? So when we break down our number, we're going to want to use some negatives. So when I think of 64, remember you need to think of 2 numbers that multiply to make it. It could be 2, it could be 8 times 8, whatever you want to do. I am going to divide this by 4. Okay, so I'm going to write negative 4 times. Now, when I divide 64 by 4, I get 16. So I'm going to write 16 right here. Now, I need a group of 3. So when I look at 16, I want to make sure that I get 2 -4s because that's what I want. I know that 16 is -4 times -4. That's where I get my group of 3 right here. And remember, my 16 got broken down, so it's gone. So the 3 4s, that's my group of 3. -4 is going to break out, and there's nothing left inside. Let's go to 7. Okay. Same thing here. We want a group of 6 this time. Okay. We can start again with the 4s like what we just did, but this time we need a group of 6. So 64, when we broke it down last time, it was 4 times 16. Now, I know that I can get a group of 3 with the 4s, but I need a group of 6. So I'm going to continue breaking down the 4 and the 16. 4 breaks down to 2 times 2, and that's about as far as it can go. So now I'm going to move on to the 16. 16 breaks down to 4 times 4. Now I already have 2 2s, so I'm going to look at my 4s and I'm going to see if I can get some more 2s out of there. 4 is also 2 times 2, and that means this 4 is also 2 times 2. So I have 6 2s right there. So all 6 of these guys, they're going to come outside. Okay. Remember your negative sign, because the negative sign is on the outside. That has to go in the front. And then your 2s. Same thing on number 8. We want a group of 5. So when we want a group of 5, we're going to break down the -32. Now, when you have this, remember the last time we broke down a negative number, like our answer was negative. So if you want to make sure that you have a negative sign at the very end, do that. 32, when you're breaking this down, just think of general numbers that multiply to make 32. So like 8 times 4 is usually what everybody picks when they're looking at 32. Now, neither of those is going to help me make a group of 5, so I need to keep going. I need to keep factoring. So 8 breaks down to 4 times 2. And I'm going to break the 4 down because I know there's no way I'm going to get a group of 5 with the 2 4s that are right here. So I know that 4 is 2 times 2. Now I already have 3 2s. So I'm going to try to get one more with my 4 right here, and I will. Or I get 2 more, sorry. So there's my group of 5 that I wanted from the beginning. Okay, so the 2s are going to come out. So you have a -2 right there. So do you see how me writing the negative at the bottom helped me remember to put the negative there? When you do your homework, it'll just tell you your answer is correct. It's just not in the right form. And when they say that, they're talking about the negative. So really make sure you got your negative in there. Number 9 is just like the one earlier. Okay. You can take your cubed root, we're looking for groups of 3, and you can split it top and bottom. So I'm going to rewrite my fraction. Cubed root of 27 over the cubed root of 125. Now, when I do the cubed root of 27, remember we're looking for groups of 3. So 27 is 9 times 3. I know I can get a group of 3 because I can break down the 9 even more. 9 breaks down to 3 times 3. So on top, I did get my group of 3 right here. So that's going to go on top of my fraction. Now I'm going to look at the bottom, and I'm going to do the exact same thing. I'm going to try to get a group of 3. So 125, we did break that down earlier. It was 5 times 25. And if I break down 25, I can get 2 more 5s, which gives me my group of 3, which is what I wanted. So the 5s are going to go on the bottom. And you're going to put this whole fraction in your answer, just like that. Got a couple more just like this. Okay. 10 gets kind of tricky because we have this negative sign and we have a negative sign on the inside too. Okay, make sure you put your negative sign all the way at the end because it's going to be really important and it's really easy to mess up your answer on these ones. So when I have a cubed root like this and then a negative in here, okay, I know that my answer is going to be negative. So I might want to put my negative sign right there too for that one. We need a group of 3, so I'm going to break down 8. 8 is 4 times 2. I don't have a group of 3 yet, but I know that 4 breaks down to 2 times 2. So I'm going to circle my 2's. They're all going to come out. Okay, so when I take the cubed root, I get 2. Okay, but I've got 2 negatives right there. Those 2 negatives are going to cancel out and be a positive 2. So I just put the negative signs at the bottom just so I remember where they are, because it's really easy to forget the inside negative and put a negative answer. Okay. On 11, you have to be careful because your number right here, you don't have one. So whenever you don't have one, remember that it's a square root. So I'm looking for groups 2. Now 2 and a negative on the inside does not work. Even though I know that 400 is a perfect square, I'm not going to be able to take the square root of it because of that negative. So on this one, you would put that it is not a real number. And that's just a little bubble that you click on your homework. I think you only have one like number 12 on your homework. Okay. Number 12 has an exponent on the inside. Okay. This just means I'm going to write 17 twice. Okay, remember that squared means that I'm writing it being multiplied by itself. Okay, so I'm going to write the square root, and I'm going to actually write 17 times 17. And the reason why I'm doing this is because I still have to do the square root, so I still need a group of 2. Now there's 2 17s in there, so those guys are allowed to break out of my radical, and I'm just going to have 1 17 out there. If you understand that the opposite of squaring something is square rooting something, you can go straight to this, right? Because you know that the square root of 17 squared, like if this is the opposite, you know that the square root and the squared are going to cancel each other out, and you're just going to have what's left inside the radical. It's going to work out like that every single time. And we're going to work on that a little bit more today and on Wednesday, because on Wednesday that's going to be really important. Okay, we got a couple more like this, and then we'll talk about some other types of problems. So whenever you have an exponent on the inside, I know that our square root and our squared just canceled, okay? When you have your number on the outside and you have this number on the inside, it's kind of like dividing all of the exponents that are in there. Okay, so you can write that down. You can write divide the exponents. Okay. You can do the inside divided by the outside. Okay, so when I write that, I have x and then I have 12 divided by 3. And these will work out pretty nicely. Like you're going to be able to divide them most of the time. So 12 divided by 3 is 4. So I have x to the 4th. Now, if you didn't like that, you can also think of it in groups of 3. So right now, like my whole goal is to get groups of 3, and I have 12 x's. So you could actually write out all 12 x's, but I know that there's a problem on your homework that has like 40 instead for the exponent, so it does take a long time. I am going to put the 12s in groups of 3. So I could sit here and I could go 1, 2, 3, there's one group, 4, 5, 6, 7, 8, 9, 10, 11, 12. They're in groups of 3. There's no leftovers. There are 1, 2, 3, 4 groups. So that's what my exponent's going to be. The number of groups is what your exponent ends up being. That's how I got my x to the 4th. Now, those are two different ways to do it. I don't care which way you do it. Both are correct, but on the one where there's 40 x's, I wouldn't want to write out 40 x's. Same thing on 14. Right here, you have exponents and you have whole numbers. So what I would do is I would do one at a time. Okay, let's focus on the 25 first. Your goal is groups of 2. 25 breaks down to 5 times 5. And so I know that the 5s are going to come out. Okay, that's going to be easy. Now with the 12, remember you can either do groups of 2 or you can do, okay, I'm going to take my x and I'm going to divide inside by outside. Okay, you could do inside divided by outside. So the 5s are a pair, they come out. And 12 divided by 2 is 6. So that works out nicely. If you were doing groups of 2 with your exponents, you would still get 6. So if I had 12 x's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 1, 2, 3, 4, 5, 6 groups. So it still works either way you want to do it, but you need to do them separately. Like do the number first and then take care of the exponents. Right. One more. Remember to do inside divided by outside. So the x just has the exponent 28, and it's going to be divided by the 4 that's on the outside. 28 divided by 4 is 7. So that would be my answer. These ones are kind of weird on 16 through 19. It wants you to find the square of each radical expression. Now what that means is it wants you to look at your problem and it just wants you to square it. So if I start with the square root of 13, okay, I am going to square it. So I'm going to do square root 13 and I'm going to square it. Now remember that squaring, it means you're going to write the number multiplied by itself. So if I'm doing that right now, I have square root 13 times 13. And the two 13s are allowed to break out. The reason why that happens is the square always cancels out the square root. So what I'm going to do is I'm going to zoom out, and I think it might be good for you to write that right next to where it says the examples. So write down way over here, the square root goes away if you square the number, or if you square it, it's going to go away every single time. So whatever is inside of the radical, that's going to be your answer. So on number 17, I am going to square that and the square root is going to go away. The only thing you have to be careful of on 17 is you are squaring the whole thing. So you are going to square this negative sign and you're going to square the square root. Now when you square the negative sign, it just goes away, kind of like the square root. So this 7 is going to be a positive 7. It's not going to be a negative because the negative goes away. Negative times negative makes a positive. Same thing on 18. On 18, we're going to square it because that's all it wants me to do. Now when it gets squared, the top and the bottom get squared, but they are both underneath the radical. So your radical is going to go away and you're just left with what's on the inside, which is 7 over 5. Now I know 19 looks weird, but everything is underneath the square root. So when you square this, the whole square root goes away, and whatever is left inside the square root is the square itself. So 6x squared minus 11 is what's inside the square root. You're going to put that whole thing in your answer on MyMathLab. So on these ones, really easy, the square root just goes away. On a bunch of the problems, it asks you if your answer is rational, irrational, or not a real number. So your rational has a perfect square under the radical. So the radical goes away, you're left with a whole number. So maybe write that down. I know it's kind of small, but I'm going to put this on Google Classroom. So if you need to come back to here, that's fine. If you need to pause, that's also okay. Then you have numbers that are irrational. Okay, so that means that there is no perfect square underneath and your radical doesn't disappear. So you can't factor the number down. Okay, I'm going to put that, I'm going to write can't factor. Okay, that's going to be an irrational number. That doesn't mean that it's not real. It's very different than not real. Not a real number, we've worked with these, and that's when you have the negative number under the radical, or when you have an even root and a negative. And we're going to look at some of those on 20 to 23, and then we'll be done. So if you need to pause to get those down in your notes, go for it. Or if you need to take a second to do that, that's fine. All right, now on these, you need to determine what kind of number this is. So you're going to have different choices on your problem. And if it works out and it's a rational number, you have to put your answer. So on all of these, I do want you to try to factor them first. So if you try to factor 169, 169 is where you have to know your perfect squares. So 169 is 13 times 13. Now remember, it's a square root, so I want groups of 2. These guys are a group of 2, so my answer is going to be 13 because those guys break out of the radical. So this one is a rational. So you're going to have 2 things on your answer. You're going to have the actual number and you're going to click that it is a rational number. Okay, 21. The negative sign's on the outside, so we're good. It just needs to go to the end. 81 breaks down to 9 times 9. Great, we've got 2 pairs. So they're going to come out of the radical, and the 9's going to join with the negative sign. So this is my answer. That's the first thing that's important. The square root disappeared, so it is rational. So I'm also going to pick rational as part of my answer. So those 2 things. Now on this one, remember that you have to separate your radical because you have a fraction. So I'm going to rewrite this with the square root on top and square root on the bottom. So square root negative 64 over square root of 25. Now when I go to break down negative 64, remember I have the even and I have a negative. So I can't factor the top. And I know that we can factor the bottom, but because we can't factor the top, they're together. So this one is not a real number because of that negative inside. So you would only pick this. You wouldn't have to actually put in a number because it doesn't work out. Now your last one is 17. 17 is a prime number. So when I go to break it down, it can't break down to anything. It's just 17 times 1. This is still a real number because it's positive on the inside. So this is an example of what an irrational number is, okay? Because the square root is still there. I can't factor it, but it's different than the last one because it's positive. So I would pick the irrational option on my homework. Now that's all I have for notes for 10-1. Okay. You are going to get a perfect square chart that I do want you to fill out and I want you to study because knowing your perfect squares are really important. So you can look at this video on Google Classroom if you need to later today, but you're going to be in the lab for sure tomorrow.